Okay, good morning everybody. So review day today and test Tuesday for my fourth period and test Thursday for my first period. Okay, so let's take a look at this review. So before I do anything, we're going to go back and see if we remember what direct variation and inverse variation is. Direct variation is like a line. It's like a y equals mx plus 0. It goes through the origin. If it doesn't go through the origin, like this one, it's going to be none. Inverse variation is just some x times y equals some number. Another version of that is if you have y equals some number divided by x. Okay, so let's take a look at the first three. So number one, xy equals 24. Yeah, that's definitely going to be an inverse variation. It fits that model perfectly, so I'd say it's inverse. Okay. Number two, that's like y equals a 3/4 x plus 3. It's got a slope, but it goes through 3. It has to go through the origin, so that's neither, none. That's neither. And then on this one, it's like a y equals a 1/2 x plus 0. Okay, plus 0 means it's going to go through the origin, has a slope, so this one's going to be a direct. It goes up 1/2. It's directly 1/2 as big as the y's, so it is a direct variation. Now from the chart, there's two ways to the chart. One is to graph it and see what's going on, and the other is to see if you can figure out, just by looking at the numbers. But I think the easiest way to do it, really, for me, sometimes is just to graph it. So I'm going to grab this graph paper and I'll throw it down. Let's see what I have. Okay, so just for me, if I graph it, I'm going to look at what it looks like. All right, so if I do this graph, I'm going to have a 2 and a 1. I'm going to have a 4 and a 2. I'm going to have a 8, 2, 4, 6, 8, and a 3. So, it looks like maybe it's a square root graph, doesn't it? No, that's neither. That does not look like direct variation or inverse. So that one's definitely neither. But let's check number 5. So number 5, again, if I graph it, it really helps me quite a bit. Gives me an idea what's going on. I can just take a look at it. Okay, on number 5, let's see, I'm going to have a 1 and a negative 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to have a 2 and a negative 4. I'm going to have a 4 and a negative 2, and I'm going to have an 8. 4, 5, 6, 7, 8, and a negative 1. It kind of has that shape, doesn't it? And let's see, if I have an x, y equals negative 8, 1 times negative 8. So it looks like it is something times something. Something times something is always equals negative 8. So I'm going to call that an inverse variation. Okay, number 6. So number 6 seems like a lot of words, but it's not that bad. So the first thing I get on number 6 is this. Inversely varies. Inversely. So let's write down this equation. Let's write down, okay, x times y equals, okay, that's the equation. Now, we get some clues. Y is negative 3, and x is 5, and if that's the case, we can get the k value. So I know k is equal to negative 15. Okay, now I can write my equation. So my equation is going to be x, y equals negative 15. Cool. So now I can use my equation. Okay, let's plug in negative 4. So I'm going to go ahead and I'm going to go negative 4 times y equals negative 15. If I solve, I'll divide by negative 4. I'll have y equals, let's see, 15/4. What's that, 1 3/4 probably. Okay, there we go. That's how you do that. 6. Okay, factor. So I would factor out an x. and I'd factor an x plus 5, x minus 5, and cancel, cancel, okay? 8, cross simplify, let's see, I would go 12 and 8, I'd cross simplify there. I'd get some y's to cancel, and I'd get some x's to cancel, so go ahead and work on that. Number 9, I would factor, factor, factor. So on number 9, again, I'm just going to set you up because I want you guys to actually do this. But on number 9, I'd factor out a 2x. I'd have an x plus 1. I'd factor out an x and have an x minus 3. I'd factor this to be an x minus 3, x plus 2, x plus 1, x plus 1, right? And then cancel, 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 okay? A bunch of stuff cancels. Boom, boom, and boom, boom, and I don't know. Anyway, number 10, I'm going to flip this one. Don't forget to flip. And then it's going to be a lot like number 8 when you cancel, 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 okay? Number 11, we're going to flip this second one, and then we're going to factor, okay? This will probably factor into, let's see, 2x, x plus 2 plus 1, and then this would factor also. This one factors into an x minus 3, x plus 2. When you flip this one, let's see, I'm going to get some factoring like this times, and I'm going to have an x plus 5 and x minus 3, and the same thing down here. We'll have a x 10, yeah, probably 5 and 2, right? X plus 5, x minus 2, and cancel, 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 okay? 12, they already have a common denominator. It is a 2x plus 1. I have to subtract. X minus x is nothing. Minus 3 minus, don't miss this, minus 3 minus 9 is a negative 12. I think that's all you can do. 13, they already have a common denominator, which is an x plus 2. And when I add, I'll get a 6x plus 12. But I think I can do more. I think if I were to cancel out, factor out a 6, I'd have an x plus 2, and then I can cancel, cancel, okay? 14, if I factor this, x plus 2x plus 3, then my common denominator is that, so I'm going to multiply this one by an x plus 2, x plus 2. Okay, go ahead and multiply it through and then subtract, okay, because that's your common denominator, okay? On the second page, cross multiply, right? Because I got a fraction equal to a fraction, so I'm going to cross multiply. I'm going to go this times this equals this times this. You will have a negative 1 equals an x times an x plus 2. You're going to have to factor. X cannot equal 0. You're going to have a negative 1 equals x squared plus 2x. Bring over the 1, factor, and you'll get negative 1 as an answer, okay? 16, what I'd like to do is first get a common denominator. So, or you can even bring this over. Oh, that might be easier. If you bring this one over, then you can cross multiply, because then you'd have a x over 3 is equal to a 4 over an x plus 2 plus a 2x over an x plus 2. These two already have a common denominator. I can combine them. Let me shoot this up here. So I have to have an x over 3 equals, let me shift this over so you can see it. I'd have a 4 plus 2x over an x plus 2, and then I'd cross multiply. X cannot equal negative 2, just right. Now 17, okay, 17. So if I factor, I'm going to have an x plus 5, and I'll have an x plus 5 and an x minus 2. Okay, now we haven't talked about this thing called a whole, but real quickly, I will have the fact that x cannot equal 2 and x cannot equal 5. Okay, now or negative 5. Now here's something, the whole, because you can cancel out the 5, that's where the whole is at x equals negative 5. The asymptote is at 2. Okay. You can use decimals if you need to, but we do know a couple of things. We know we're going to have a vertical asymptote at 2, and I'll let you guys use decimals to get your answer, okay? And then finally, 18. Okay. 18 is going to be a brand new problem, and it's a little bit like the extra. So it's a work problem. So Beth can tile a floor in 10 hours by herself. If she works with Tommy, so if they work together, here's Beth and Tom, if they work together, they can tile a floor and they get the job, one job done, okay? Beth's work plus Tom's work equals one job. That's one job, okay? Now it's a ratio, okay? So Beth can do the one job in 10 hours. But we don't know how long Tom can work. It doesn't say. But if Tom works, Tom can get the job done in X over, we don't know how long it takes Tom, but together they can do it in 5.8 hours, okay? So this is actually 10 over 5.8. There you go. All right? Plus Tom's. You have a common denominator. You just need to solve and get it. And this is a little bit like what you're going to see for the extra, so I'll let you think about how that works. Okay, that's all I have. I will see my first period class on Monday. In my second period class, I won't see you guys till Tuesday. Okay, so we'll get this loaded up so you can look at it.